This week we're talking about thunderstorms. So I just thought I would look at the thunderstorms that were going on today and let's figure out why. Uh, this is a radar for Wakefield, Virginia. Notice it's a pretty good thunderstorm here. Actually, a severe thunderstorm warning for this storm. There's some others down here in North Carolina. There's another area of severe thunderstorm warning for one moving over the Outer Banks right now. Lots of them here is I-95. So lots of these thunderstorms are right along or just to the west of I-95. There's some right here as well. Small area moving through the James River. Matter of fact, I was just out for dinner and I got hit by a thunderstorm. Actually, a rain shower pretty much in this area. So I wanted to look with this. Let's take a look at some satellite images first. We'll just start right there. So this is a visible satellite with lightning superimposed on it. So you can see we were looking at some pretty heavy thunderstorms here, one down in this area as well. And look at them all developing right along this one area we were looking at out there just to the west of I-95. Lots of lightning. Matter of fact, the more red and the darker the red into the purple, the more strokes per minute that the lightning is mapping. Uh, You can see some thunderstorms were along the eastern shore here by Ocean City and now have moved off the coast. So, pretty good example of how you can take advantage with a satellite and combine it with lightning to see where the most intense thunderstorms are. Uh, Another thing you can use with satellite is infrared. It fascinated me here. Notice all the thunderstorms that initially developed just south of the Virginia North Carolina border, and now look at them growing. They're growing to the north. New ones are forming. They're not necessarily moving that way, but there are a whole bunch of new thunderstorms growing and back in here. There are other thunderstorms that obviously you can just begin to see here in Ohio, for example. One of the reasons I focused down here was because we have a severe thunderstorm watch out across my area right now. So I wanted to look at that. So let's go from this just to see what's on the current weather map in this area. Well, it was interesting to me that there's a big warm front here coming across Ohio. Weak low moving across Pennsylvania here. The front kind of dips down right along the eastern shore here. Another little low there. These are very, very tiny lows. But I wanted you to notice right along here the Appalachians. There's a low pressure here, and there's a high pressure back to the west. Well, what that is, when the winds move across the Appalachian Mountains sometimes, they form low pressure on the eastern side of it, right along the east slopes of it. And that's what has happened here. Now, as the thunderstorms develop, they begin to develop high, the downdrafts get cold. We know cold air is more dense. So they actually develop a high pressure system behind it. So we have a beautiful little couplet. That is where the thunderstorms are most likely to generate and move with this system as it moves to the east. Notice there's plenty of moisture out here. Dew points in the mid to upper 70s. Temperatures in the low 80s, even low 90s out in here. Lots of southerly wind in here, even coming off the Atlantic as well. So at the surface, we have convergence probably right along this boundary, especially with this high pressure sitting here, pushing to the winds to the east, and that's going to the west. So we have convergence there. We can see the thunderstorms blossoming. We saw them on radar. Now let's take a look. Is there anything going on above this level? Well, we have a jet streak. You can actually see it right here to the north, but we also see some of it right in here because notice the winds are 60 knots here and they're 40 to 45 knots back in here. So this jet streak, this was at 8 a.m. this morning, has probably continued its track east. Well, if it has, like you would expect it to, this part of the jet would be over this area of Virginia, West Virginia, and Pennsylvania by now. So if that's the case, we have divergence that's over the area probably right now, helping to aid these thunderstorms. We have a boundary at the surface that's causing convergence at the surface. We have divergence aloft. So we're getting what you really need now is the instability. And dew points in the mid to upper 70s, temperatures in the low 90s are probably yielding that. And the National Storm Prediction Center, which forecasts severe weather and handles most thunderstorm watches. So let's take a look at one of their maps. It's a little confusing, I know. The dashed lines are moisture, solid lines, temperature. Lots of really hot temperatures down to our south, a little cooler up by us. But notice there's a coolness. Temperatures are a little cooler here, a little warmer out ahead of that boundary. So with that, I wanted to, we've talked about convergence. Well, one of the interesting things is there's also something called moisture convergence. So think about the air converging, but we're pulling in moisture at the same time. This is an excellent predictor for where thunderstorms might form. The stronger the moisture convergence, the stronger the potential for thunderstorms. We can see here moisture convergence just probably where the divergence area was up aloft, and then we also have it coming down along this old boundary in that trough of low pressure we saw out here. To the west of that high, we also see some moisture convergence right along the Appalachians there. We saw all those thunderstorms develop down to the south. Well, look where the moisture convergence is, just to the south of that area. You would expect the thunderstorms to continue growing down in that ballpark, going southward, expanding in size, probably along the coast, sea breeze front. Again, all this is showing is that air is converging, and at the same time, moisture is converging. So we're enhancing the chance for instability by bringing in air that's warm, humid. So let's take a look up aloft. And I mentioned about the possibility there being some possible divergence. Well, here's that jet that was coming through at 300 millibars. And there is some weak divergence down in this neighborhood. Better up further west where the stronger the jet is, and further north. But there is a little bit there. Let's see if we can find anything else. Oh, maybe about 500 millibars, anything there, not much. Pretty good wind out here. Wind's relatively weak. Look how light this wind is at 500 millibars across my area. 20, 10, 15 knots. So you would expect these thunderstorms to grow and not move real fast. So finally, the thermodynamics. CAPE. CAPE is convective available potential energy. What it is, hey, the bigger you are, the more potential you have for lift, more instability. It's just saying this is the potential instability. If I heat it up, throw in moisture, this is how unstable I am. And we can see here, for example, out ahead of that trough, 3,500. That's a pretty good sized number. Another big number, 2,500, 3,500 in here. So there's some really good sized CAPE out ahead of that initial line. You would expect thunderstorms to continue to develop and grow in that area now. So that's just a surface-based CAPE. We could look at how high these clouds are or the level they can grow to, but let's take a look at 3-hour based, surface-based CAPE change. And I will bet you, yep, lots of potential in this area as well. Finally, I wanted to look at wind shear. Wind shear is a method of looking at how thunderstorms can keep growing longer and longer. You expect severe thunderstorms when you basically have about 40 knots of wind shear. That's why I was kind of surprised when they put the watch out. You'll notice we have about 30 knots of wind shear in here. That's enough to maintain an organization of thunderstorms, not necessarily enough to make a lot of severe weather. However, if you're out here in the Midwest, Indiana, across the parts of this area, pretty strong wind shear. So you have potential for some severe weather out there as well, especially along the outflow right down here where the front is. So all this is ways we look at predicting thunderstorms. In this case, these thunderstorms are starting out as individuals, but they're beginning to merge together to make more of a cluster or a mesoscale convective system. Last night at my house, I had a big area of thunderstorms to my south again that built north. Out to the west, there was thunderstorms as well. They basically merged right around my house, a little bit to the west of it, moved across, gave heavy rain, and they maintained themselves, moved well off the coast and into North Carolina in a big shape of very high convection that just moved off the coast. However, there was a large area of light rain behind that, or moderate to heavy rain sometimes. And that was an indication these mesoscale convective systems have a lot of thunderstorms out the initial. They have a few embedded thunder and all behind it, but mainly it's a large area of rain they cause. And each one of these thunderstorms is feeding off the other thunderstorms to help them keep new ones developing. So, this is what you're going to be learning about this week. You're going to be talking about it. Hope you get something out of it. Now, let me know if you have any questions about this.